Greetings everyone. Today we're going to explore graphing piecewise functions. For this, you'll want to make sure you have our note sheet, or if you don't have a printed copy, at least some graph paper to go into your notebook. All right, first let's talk about what is a piecewise function. And if you have notes from our previous lessons, you probably have this already written down. A piecewise function is made up of pieces of different functions that are a result of different domains or x values. Now keep in mind, even though these are pieces, they're not inequalities. So we've had confusion in the past. There's no shading, there's no dashed lines. We're just taking an entire graph and looking at only a piece of it. So again, to break it down simply, they're pieces of different graphs. So let's just jump right into equations. If you need help with graphing lines or absolute values, you'll want to see previous videos. So let's start off with the first function. Now, there are a couple of ways to approach this. I'm going to start by graphing the entire line and then erasing the piece that I don't need, okay? So if I look at this as a linear function, I have a y-intercept of -4. And my graph is going to, or excuse me, my slope is going to be 1, so rise 1, run 1. Now I tend to graph a lot of dots because I know one of those dots is going to be part of my limit or my constraint. So this would be what you are familiar with already, graphing that line. So what we're looking at now is the limit. The limit says we want to keep the x values that are less than 3. So if I look at this idea, this wall, this x equals 3 line, I want to keep the part of the graph that's less than that line. So I'm going to use a different color here. If I'm looking and I say purple, I want to keep the part of the graph that is less than 3. So I want to keep all of this piece of the graph, which means I'm going to erase the other half. Okay? Now that little blue line was just a visual aid to help me see the left side is what I'm keeping. Now the only other piece I need to consider and be careful about is it says less than. Less than is considered open, so we want an open dot at 3, -1. Let's take a look at the next function. I see this line of -2x plus 1. We're dealing with slope-intercept form. I'm going to start at 1. My y-intercept, and my slope is -2. Down 2, right 1, down 2, right 1, and so on. Now I'm going to graph both directions for a little bit, but keep in mind, I'm only going to ask you to graph functions, piecewise functions, which means if it's a function, it still needs to pass the vertical line test. So what does that mean? That means this dot, this dot, this dot, they wouldn't pass the vertical line test, right? So I'm still going to graph the whole thing temporarily because I want to show you that erasing piece. So I filled the graph to the right. Now I'm going to look at it as I need to keep the values that are greater than or equal to 3. So again, I'm at this sort of 3 line, right? And I want to keep the values that are greater than it. So I'm going to use purple again. The values that are greater than 3 is this part of the line. Okay, that's what I want to keep there. So I'm going to take my eraser and I'm going to erase the pieces to the left that are not included. Now it says or equals to, which means there should be a solid dot at the value 3, -5. So if I tidy up this graph a little bit, it's a little bit messy. We would have these 2 lines. We would have no vertical lines. That was just a visual aid. And I have my open and my closed dot at 3. So if I think about that vertical line test, wherever I draw a vertical line, I only exist once. So that's good. We pass the vertical line test. Keep in mind on these examples as well that we have been working with interval notation. So remember that this is an inequality, but we could also write it as negative infinity to 5. So we want to be able to be fluid in that thinking of how the domain is written. Okay? All right, let's look at the next one. My first function here says the absolute value of x minus 3. I'm just going to make a little side note here. So that negative 3 is a horizontal shift, right 3. So if you need more instruction on that, that would be in our other video of transformations of absolute values. So what that means is my graph, my vertex, my parent function is shifted to the right 3. There is no stretch or compression out front. Technically there's a 1 and it's positive. So that means it's a positive v going up and its change is 1 over 1. Right? So I've got this perfect parent function v shifted to the right 3. So if you need more help with graphing absolute values, see my other videos. What we're concentrating on today is that limit. We want to keep the values that are less than 5. So if I look at 5, here would be my boundary line, right? And I want to keep what's less than 5. So from 5, I want to keep this little piece here. And then I want to keep the piece going all the way up to the left, okay? So I'm going to take my eraser and I'm going to get rid of anything that's to the right of that line. Now, I want to pay attention to what type of point it is less than, which means it is open. So I need an open dot at that value. If you're worried about that open dot being clear, maybe consider regraphing just a little bit. That way it doesn't look like there's anything in the open dot. I encourage you to use a pencil so that you can make these changes as well. Let's take a look at the next function. The next function that I see says 1/2 x minus 2, so we're linear again. We're going to go down to negative 2, and our rise, run is half. Now, I could go to the left, but then it wouldn't pass the vertical line test, so I'm not going to waste my time. I'm going to graph what I have so far. Now, again, my limit is at that value of 5. I'm talking about the values that are greater than or equal to 5. So I'm imagining this line temporarily. I want to keep the values bigger than 5. So I'm actually at a halfway mark here. If you take a look, if I was to plug in 5 into the function, I would have 5 halves, which is 2.5, right? Minus 5. So let's take a look at what that is, right? We would have negative 2.5. Whoops, what did I do wrong here? Minus 2, sorry, that should be minus 2. Let me fix that. If I subtract 2, I would have 0.5. So that makes sense. When the x value is 5, the y value is 0.5. So I'm going to do a solid dot at 5, 0.5. And my graph is going to continue or be greater than that value. So I'm going off to the right, which means I'm going to erase everything to the left of that value of 5. All right, so here is my completed piecewise function. It passes the vertical line test. I can't stress that enough. And then even at 5, there's one open and one closed, which still passes the vertical line test. All right, let's take a look at this next one. This one's unique in that we have 3 horizontal lines. So let's start with 3. If I graph the line y equals 3, don't need any dots, but now let's take a look at our restrictions. All right, in interval notation, it would look like this, so be fluid and comfortable with both. That means that line should have an open circle at 0 and a solid dot at 2, and I'm containing what's in the middle, right? I only exist from 0 to 2, which means I'm going to erase everything outside of that limit. All right, let's try another one. The next one says 1. All right, so I'm going to graph y equals 1, horizontal line through 1. My limit this time is between 2 and 4, an open circle at 2, a solid dot at 4, and I exist in between. I do not exist outside of those restrictions, so I'm going to erase the rest. All right, let's take a look at the last one, 5. Graph the line y equals 5. And I'm looking at these restrictions here of 4 to 6. 4 is open because it's just less than. 6 is closed because it's or equals to. And I'm going to connect in the middle, which means anything outside of that does not exist anymore. Now, we call this a step function because we often create restrictions and put them in an order where we have little pieces of steps that go up as you read the graph. So something unique, something you'll see in future math classes, and so we're just introducing it here. All right, so that's our introduction to graphing piecewise functions. And what I encourage you to do is find what works best for you. Does graphing and then erasing work best? Are you comfortable with starting with the limit point? Feel free to use your marker boards. I feel like those are easier to erase, so sometimes that's a good place to start. Make sure, as always, that you check out Google Classroom, see what your task is for this lesson. If you have questions, let me know. I can definitely throw some more examples at you. And until next time, I hope you have a good one.